Hey there. Here today I'm talking about the two-sum problem. So in the two-sum problem, we are given an array of integers and a target number. We need to find the two numbers in the array that add up to the target, and our goal is to return the indices of those two numbers. So here we see that our target is 9. In this example, the numbers 2 and 7 add up to 9. So here we have 0, 1, 2, 3. These are the indexes of each of these numbers placed in the array. So we would want to return, because 2 and 7 is our answer for this problem, we want to return the indices, which is an array of 0 and 1. That is our answer. Let's start with the simple brute force solution. The idea is to check every possible pair of numbers to see if they add up to the target. So here for the brute force method, we want to loop through the array. So in the beginning of this loop, we have two pointers in the array. So this means that there are two loops. So the first one, let's say we have variable I that points to the first index and variable j that points to the first index. Well, obviously we don't do 2 plus 2 because we can't use the same one twice in this problem. So we move it over. 2 plus 7 equals 9. Boom. We already got our target. And now we can return the index of I, which is at 0, and j is at 1. Here we just return the list of 0 and 1. Our target is 18. Here is 18. So we start from the beginning. So we iterate once. Boom, 2 plus 7 is 9. Nope. 2 plus 11, 13. Nope. 2 plus 15 is 17. Nope. Alright, reset. On to the next. Usually it would start here now. So now we do 7 plus 11 is 18. Okay, so now we got it. We returned the values of 1 and 2, and that is our answer for target of 18. So we see this is a very long process, and eventually, if the array is long enough, we could see an O of n times n, because we're iterating through the array every time per loop, and this is an n squared uh, time complexity problem. And we don't want that. So now that we decided that we wanted to use a faster and better solution than n squared, we're gonna do a simpler solution, or we could say more complex, that's using a hash map and one for loop. So how do we do this? We first have the same thing. We have a pointer that points to the first index of the array at 0. And in the hash map, we hold a key and we hold a value. The key is going to be, let's get rid of that so it doesn't get confusing. It's going to be the value that is held in the array. So a value, what do I mean by that? Is the 2, that's a value. Is the 7, that's a value. Is the 11, that's the value. Is the 15, that's a value. So 2, 7, 11, 15, that's how it's going to fill out. Here we have the index. And what do I mean by index? Where the value's position is in the original array. So the 0, the 1, the 2, and the 3. And what does this mean? This is just going to be what we loop through, and this is where the math happens, the magic happens. So first, we want to set a target. So we're going to say our target is 17. So we start at I equals 0, move down here, we do the target minus the current variable we're on, and that is 15. So we first check if we have a 15 in our hash map. Oh, we're at the beginning, so there's nothing in our hash map. Nothing happens. We go to the next. But before we do that, we have to add this into the hash map. So what this means is we're going to add the value of 2, and we're going to add its index, 0. We move to the next. Index is at 1. So we move down here, we check, okay, target minus current value, that's a 10. Boom, we check if there's a 10 in our hash map. There's no 10, so we up back up here. We add it to our hash map. So we have a 7 as our value, and 7's index is 1. So we're on to the next. And you see how this is going. It's just a repeating process. We can start visualizing the code. 17 minus 11, which is 6. We throw that in here. We check if there's a 6. No 6. All right, we want to add it into the hash map. 11 and 2. Finally, we're on the last one. Let's hope we have an answer here. 15. We go down here. 17 minus 15. We have a 2. Oh, looks like we have a 2. Ding, ding, ding. So we don't have to add anything to the hash map, or we found an answer. So now we check what the index is, because we know we have to return the index. We're not returning the value, we're returning the index. We have an index of 0, and we have an index of 3, which adds up to 17, so we want to return a 0 and 3. Boom, that is our answer using our hash map and one loop. And because it only used one loop, instead of the brute force version where it's n squared time complexity, we bumped it down all the way to O of n, which is huge. This is huge. Google's gonna make millions of dollars now. And let's see how we can write down the code. Okay, let's analyze what's given to us. We have a clash solution, public, and we have a function that we need to return a vector with int variables, and we have a function called toSum, which is our problem, and we are getting a reference called nums that is a reference to another vector of integers, and then we have a target that's an integer. We have a target, and we have a vector of ints. So to start this off, we need to make a hash map. So in C++, that is an unordered map. And what do we put in our unordered map? We want the value that's inside the nums vector, which is an integer, and then we want the index of where that variable is in the array. That's how we're going to answer our problem. And we're going to call this toSum map. It doesn't really matter what you call it. I'm just going to say it like that. And now we want to make our for loop. So we start at 0 like we did earlier in the presentation. But what do we want to stop it at? We don't want it to be iterating more than the nums list, the length of list. So we just do a simple command nums.size. And what this does, we start at 0. If we have an array of 8 elements, it goes from 0 to 7. But the size is still 8 elements. So we don't want it to hit 8, or we're going to, in C++, we'll get a huge error, give us a lot of headaches and a lot of problems. If we try to grab a nums 8, we're going to get an out of bounds error if we set this to equal. So that is why we want it to be less than, because I will max out at 7, which is under 8, and we'll reach the end of the array if needed to be. So we do that, and we iterate by 1 every single time. And here we want to reference back to the slide. Well, what did we want to do? So we wanted to find the variable, we'll call it x, which is the target minus what was in the array. So we do target, which is this, minus nums I, and that's going to be our x. So let's call int x equals target minus nums I. So now we want to check the hash map. So if toSum map, that's what we called the hash map, what we did earlier, count x. So in C++, in an unordered map, the key is the first value in the key value pair, and the value is the second value. In my explanation, we set the key to be the variable inside the list, and then we set the value as the index of the array. Let's say target is 15, and let's say nums I is 12. Right now, we are doing 15 minus 12, which equals 3, and we're checking if there is a 3 in the two-sum map. So with that, if there is a 3, then boom, we can easily just return. We're going to make a vector here. This is a shortcut of making a vector. Two-sum map. And then we're going to grab x, which is the key, and we're going to grab I, which is where we are in the map. And this is our answer. So this is basically like returning a 0 and a 3, if that's where the index is for this, and that's where I is. If not, then we have to keep iterating to some map, and we grab the current value, and we set that key value to the index. And if nothing happens, then we return nothing. So let's test this out. We're going to submit. In here that we see it's accepted, and it beats 77.85%.